back, guys. So let's try to start with the very basic, because whenever we do something, the idea is to know why we are doing and how we are doing, right? So that is the motivation part. And like my previous session, let me try to make it more interactive. So let's start with this. So let's try to understand what are what are or what is a dummy variable. You can have R or is depending upon how we are approaching is, and this will become clear a moment from now. So basically, when I was in the morning thinking about how to open up the discussion, I thought let's check out in the dictionary, English dictionary, what is the meaning of the word dummy, And if you check the English dictionary, the word which is written about dummy is basically dummy means it's a replica, okay, or it's a representation of another variable, okay. Now, if you are, and please try to make it interactive. I think I have already are you guys able to hear me, all of you? I think, yes?
Yes, sir, you're audible.
Yeah. So the dummy variable is basically, it means the replica of some other variable for which we know that there is information, but the idea is how to capture the information. Now, you can always argue that if I'm, what we did in the previous class, if you see, when I'm running a regression, I typically have a model like this, where X is my explanatory variable, epsilon is my error terms, and Y is my dependent variable. Now, typically what we assume that X and epsilon, these are not related or independent of one another. Now, not related means, because if they're related, then what happens is you have if they are related, if they have X and if X and epsilon are related, then you have a problem of what we call endogeneity, okay? Now, the reason I'm mentioning about endogeneity over here, because I just now said that, so when you have a problem of endogeneity, you actually don't use X, but a replica of X, which we call instrumental variable, and something we will discuss in maybe another session. Now, the reason I'm starting off with this replica, or so the idea is, therefore, in what way this instrumental variable is different than the dummy variable, something that we are going to discuss today. Now, the difference between the instrumental variable and dummy variable, first of all, is in case of dummy variable, you still have X, but the X here are qualitative or characteristic variable, okay? Now, what does qualitative or characteristic variable means? This is in the context of dummy, okay? This is in the context of dummy that we are talking about. Now, what does the qualitative or characteristic variables means? That unlike the multiple regression where we assume that X is basically a quantitative variable, we here are assuming that quantitative variables means it comes with a number, right? So if you have an X which is quantitative variable, and that X, for instance, I'm trying to measure let's say that Y is my wage rate, okay? And this X can be, let's say, your number of years of education, Okay, so the moment I say that number of years of education, you may, in this particular class, you may have, let's say, 7 professors with who have given, let's say, 16 years of education. You may have 4 other professors who have given, let's say, 20 years of education. So these are numbers, right? But if I were to say that whether we are dealing with the teachers who are belonging to, let's say, 4 different categories, namely either you have passed class 10 standard exam. The second category of teachers are the ones who have passed 10 plus 2 or 12 standard exam. The third category of teachers are the one who have passed undergrad degrees. And the fourth category of teachers are the one who have passed, let's say, master's degree. Okay. So the moment we are saying that there are categories rather than quantity, or this can also be other qualitative can be, for instance, which region in India you are likely to get more wage rate. For instance, if you are working in southern part of India, or whether you're working in eastern part of India, or for that matter, you're working in, let's say, western part of India or northern part of India, right? So if I want to capture which region in India you are likely to get a higher wage, provided you work in that region, that is not a quantitative variable, but a qualitative variable. Why? Because I don't have any numbers, as in what I said a few minutes back, as in I'm trying to capture the number of years of education pertaining to any particular teacher. Okay, so here I'm saying that whether the teacher is likely to do a job in southern part of India, or for that matter, northern, eastern, or western part of India, and depending upon where he or she is working, how much money that is, whether the probability of getting money is more in the eastern or western or southern, or so that is the qualitative variable. Okay, if you have any question, please feel free to write in the chat box, because only then it will become clear. So let me start off with saying, therefore, these 2 important distinctions in the context of multiple regression model. The basic assumption we are starting off with is X and the error terms are not related. Okay, that is number 1. If they're related, then we have a problem of what we call endogeneity. If we have a problem of endogeneity, I should look for some replica or some other variables that represent X variable, which I call instrumental variable. But that thing happens only when X variable is quantitative in nature, meaning it actually has some numbers. On the other hand, if the X variable is qualitative in nature, then we are using something called dummy variable to capture the impact of that particular characteristic. Okay, here also, in case of dummy variable, please note, here also we are assuming that X and the error terms, these are not related, or there is no correlation, or the covariance between X and error terms is still 0. Okay, but here X is basically, what I'm saying is, I'm repeating over and over again, it is qualitative in nature. Okay, it is not quantitative in nature. Okay, is there any question, guys, what we are doing? Okay, so this is about in a way what the dummy variable in a very simple term means. We are trying to capture the impact of certain characteristic. Okay, so I've just given you the example of whether if you were working in which part of India, east, west, north or south. So it's the characteristic, right? So likewise, I can also argue that let's say you are in the US and you are in the job market, and you're trying to let's say you're trying to enter into the job market. So I can say that depending upon your ethnicity, meaning that whether you are black, white, brown, or yellow, that will determine, or whether given the same level of education, given the same level of education, is it that the ethnicity, meaning that if you are coming from white or background, or you're coming from a black family background, or you're coming from yellow, which is meaning that you are Oriental, either Chinese, Japanese, or South Korean, or for that matter, you are coming from a brown family background, for instance, Indian, Pakistanis, Bangladeshis. Do we see for the same level of education, there is a difference in wage rate, given the conditional upon the color of your skin? Okay, so or the characteristic of your I can actually extend this. So I can actually extend this in terms of color of your skin. I can also extend this in terms of, let's say, whether you are a male or female. Okay, so that would be the gender aspect of it. Okay, I can also extend this in terms of the continent you belong to, whether you are from Asia, whether you're from Africa, whether you're from Europe, so on and so forth. Okay, so the dummy variable, in a very short and to cut the long story short, dummy variable try to capture the impact of any variable which is qualitative in nature. Clear, guys? Likewise, we can use dummy variable for two other important things. So let me erase this. We can actually use the dummy variable. So the question is, one is why dummy variable? Because we want to capture the impact of any qualitative variables on the explanatory variables. Okay, on the explained variable. Okay, so for instance, the example which I've been giving over and over again, that what are the characteristics that determines the wage rate? Is it the ethnicity? Is it the region you belongs to? Is it or for that matter, is it the continent you belongs to, so on and so forth. There is another, there are two. So one use of the dummy variable is to capture the qualitative aspect of the data. The second is to capture, and this is very important, the second is to capture any structural break, any break. So before I come to the structural break or shift in the data. Okay. Now let me explain what I mean is, let's say, and I'm sure that all of you know that in India we have this liberalization and globalization happening. Okay. So if I were to plot, let's say, GDP data over time, India's GDP data, and this is my time, and this is my GDP. And by the way, I'm going to show you all of this in Excel and Eviews. So please bear with me, because first let me tell you the story, and then I'm going to show you with data as how you capture this qualitative aspect. And meanwhile, if you have any question, please write in the chat box. Okay. So let's say that I'm trying to plot India's GDP data. Let's say this is India's GDP data, and I have data between 1950 up to 2000. Okay. So you will find that in the year 1991, we have something called, in the year 1991, let's write it down, we have something called economic liberalization. Okay, so this is the year. Okay, this is that watershed moment, as we'd say. So what was happening is, if you look into the data, and you don't have to believe me, between 1950 and 1991, you will find that the India's growth rate of GDP was around 3%. Okay, the 3%, actually it was less than 3% before 1980, but it went up to a little bit more than 3% after 1980, when for the first time the government started thinking about opening up the economy. Okay, so that was the time when the Maruti, the famous example, which I keep on giving. The Suzuki company in the Japan, they were allowed to manufacture car in India. Okay, so that's how this Maruti came into. Of course, with the majority of the stakeholder was the government of India. So that's how. But the actual liberalization, globalization started happening in the year 1991. So, and after which there is a big jump in the India's GDP growth. So, if I'm writing this as India's, let's say this is India's GDP growth, what you are going to see is before 1991, maybe this was growing like something like this. And after 1991, what happened was two things which happened. One was there is a big jump in per capita income, and also the growth rate increase. Okay, so what we are trying to say is there is a structural break. This is what I meant. There is a break in the data. So this is also called the structural break. Why structural break? Because something in the economy happened, some in terms of policy, which kind of has led to a huge increase in per capita income and a jump in our the gross domestic product, which is a national income. Okay, so if I were to capture this I can capture using again dummy variable. So that is the second use of dummy variable, and I'm also going to showcase you this. Now, what is the third use? And the third use is you can also use the dummy variable to deseasonalize the data. Okay, deseasonalize the data means let's say that I have a quarterly data. Okay, and I have 4 quarters, as you know, Q1, Q2, Q3, and Q4. Okay, if I have 4 quarters, and if I have a quarterly data, then what it means is in India, as you know, that during the festive season, typically, which comes under the, if I'm looking into the, let's say, calendar year, then the first quarter is between January to March. Okay, and the last quarter Q, this is my Q1, and the last quarter is between October to December. Okay, now this is my, so typically what happens is you will find that during Q1 and Q4 there is an increase in sales. Okay, why? Because the Q1 quarter is typically the harvest quarter, when the harvest season comes in the market, and Q4 is basically the Christmas or the Diwali or the festival season, where people tend to spend more. So therefore, if I want to deseasonalize the data, meaning that you have to take out the impact of the seasonal factor, I can actually do that using the dummy variable. So these are the broad three usage of the dummy variable. Now again, you may ask that why you need to deseasonalize the data. Think of you as a, let's say, an entrepreneur. Okay, you are planning to chalk out how much of the capital you are going to utilize over the next 4 or 5 years. So you don't have to depend on the seasonal factor, right? Because seasonal factors are something which happens during a particular season, and therefore you want to see that what is the organic growth in your business activities, and for that you have to actually take out the seasonal factor and try to see what is the organic growth in your activity, and on the basis of that one need to deseasonalize the data. Okay, any question, guys? Please feel free to write in the chat box. Okay. Now, given this background, let me start with the data. And what I'm going to do is, I'm going to show you both in Eviews as well as in Excel as how you can actually operate with this dummy variable technique. Okay, so let's let's close this. Let's try to open this particular file. So what I have here is, so the first thing what I'm going to do is I'm going to work with deseasonalizing the data. Okay, so this is, I'm going to show you. Now for here, there are a few things which you should keep in mind. The first thing which I've not said is I don't know what type of participants are actually here today in this program, but if you're not from mathematical background, so there is something, I'm just writing this, I'm not, there is something called dummy variable trap. Okay, now let me explain what it means. So typically when we have a equation, let's say y equal to alpha plus beta x plus error. So basically it is a number of, so this is my dependent variable, right? And this is my independent variable. So this is the number of observation, right? So I can have data from as which can be written as y1, y2. As you can see here, I have the number of observation, right? So it goes up to there are 28 data, right? So this column will go up to y28. Now the alpha, when you run the regression, is the constant. Okay, so the constant is typically written as 1 because alpha is just the intercept, right? So this is a scalar. So this first column would be something like this: y 1 and 28 different types. I have to rewrite this as 1, and the second column would be my x. Now x can be, here I'm choosing 1x, it can be multiple x. Okay, so without trying to make it look complex, so typically what you have is a matrix of x which looks like, let's say I have k number of x. Okay, so and this would be like x k2, and then I have x up to 28, right? So this will be the first column 28 comma 1 and x k 28. Okay, so this is how it looks like. Okay, now what dummy variable trap is saying that this column and one of the x should not be similar, either in terms of column or the row, because then there is a problem of because the formula for the beta, again, I promise that I'm not going to go into the technical, but for some of you, I don't know which background you're coming from, but the formula for the beta is x prime x inverse. So if you're coming from a mathematical background, you will know that if one of the row or one of the column are similar, then I have a problem of singularity, and therefore I cannot estimate the beta. Okay, so to cut the long story short, in case of dummy variable, you always drop one of the variable. Because why? Because in this case, I'm capturing each quarter as dummy. Okay, so let's try to figure it out in the sense that how we are doing this. So the first thing is, here what I have here is, let me introduce you the data. I have the sales figure, okay, and I have RPDI, which is my real personal disposable income. You also have the consumer confidence index, which I'm writing as conf, and I have a trend. Trend is a time data which basically try to capture that over a period of time. In addition to what we are seeing in the seasonal factor, is there any change in the data, in this case the sales figure. So in the context of what we are discussing, The trend variable will be very important if we were to capture event like globalization or liberalization. Okay. Now, before I do that, so what I'm trying to do in this particular Excel exercise, and this I'm also going to show you in using the Eviews, the first thing I'm going to do is I want to check whether there is some seasonality in the data. Okay. Now, the D2 is basically quarter 2, D3 is quarter 3, D4 is quarter 4. I have dropped D1 because of the dummy variable trap, and anything which get captured in the intercept will be taken as the value for quarter 1. Okay, let me repeat. I have actually dropped D1, which is the dummy for quarter 1. Why I have dropped? Because of this particular event called dummy variable trap, because I cannot invert the matrix, something I wanted to show you. And then what I do is, okay, in fact, I can show you here, even if I use the D1 as a quarter, let me, you guys can see my Excel file, right? Yes? You can see my Excel file, right?
Yes, sir.
Okay. So in this case, then what is happening is, first let's try to create this. There is a command called if. Okay. Now this is a logical function that we are going to use, and the best part is if this is equal to, let's say, because this is so the best way to do this is, let's try do this. Let's insert this, and let's try to put it over here. Control V, and also insert this, insert, and then I rewrite this as the 4 quarter so that you know what is happening. I go here. I have to go to base spatial. I have to transpose the data. And this is what I get. I have to actually, if I pull this, I actually have to make this as, because I'm creating this dummy. So copy, and then I just paste this. Okay. So I've got this 4 quarters. So all I have to do is I have to use this command if, and then make this as equal to D1, then it will take value 1, otherwise it will take value 0. So there you go. So if I click on this, you can see that for each quarter 1, I'm getting a value 1. Okay. So likewise, I can also do it for quarter 2. The only thing is here, what I do is if, and then I write this thing equal to D2, then it will take value 1, otherwise it will take value 0. Okay, so this is what I'm getting. If I'm doing this, you see that for each one of the quarter 2, you see, I'm getting the value. So you don't have to do this manually if I use this if function. Okay, so I can also do this for again, I have to go here, but now I'm saying, let's say I'm writing this 3, and then 1, then 0, and again I do it. And now for the D4, again, if logical test equal to, now it will be D4, and then 1, and then 0. This is what I'm getting. So point to note here is, you see that I'm just using this command to create this dummy without writing this up in the longhand, okay? So now, what we are again doing, we are trying to deseasonalize the data. Deseasonalize the data, the way you do it is, you first run the regression, okay? Now, before I run the regression, let's try to see that whether this dummy are statistically significant. So for that, let's try to look into the sales price. This is my sales price. And let's try to look into this. And you have to use this command 1, 2, 3 so that I have this. So the first thing I should do is, let's try to run a regression, okay? Now, what I said, that if I'm using the intercept, I cannot use the 4 of them, because if I add this D1 equal to D2 equal to D3 equal to D4, if I add this thing, as you can see, if I'm adding this from here to here, what I'm getting is a column of 1, and this mimic my intercept, okay? So therefore, I have to drop one of the variable. It doesn't depend which one of the quarterly dummy I'm dropping, because the results are going to be similar. So let me show you that, because let's try to see this data, and then I go to data analysis, and then I go to regression, and my input range is this Y variable. Output range, let's take this 3, because if I, as I said, that if I take 4, okay, first let's take 4 and let's try to see what I get. You will find that one of the dummy variable is going to be 0, because that is being taken as the intercept. So let's say that I click on this. So it's saying non-numeric data, because I have not clicked on this label. So if I click on this label, basically, what are the non-numeric data? It is actually the sales figure and this dummy which I've written. So if I rewrite this, you see that it is automatically dropping D1 as the variable, okay? So this is the dummy variable trap, that I cannot simultaneously use all the, I have to drop one of the dummy. And the dummy which I'm dropping here is quarter, doesn't matter. Let's now try to drop dummy 4, okay? So let's try to drop this this guy over here. Let's try to drop dummy 4. We are dropping this first, okay? And then we'll drop, let's say, dummy 2, okay? So first we are dropping dummy 4, and let's try to see what happens. So if I go to here, and data analysis, regression, okay, D1, D2, D3. So here it is going up to F, right? D2, D, E, F, which is not going up to G, because I'm dropping G. So let's say I'm getting here, and this is what I'm getting, okay? So let's try to interpret this. What it is basically saying is, that the sales figure, the mean sales figure in the, let me write it down so that we can actually, mean sales figure in the first quarter, because I have, wait a minute, I've dropped fourth quarter, okay? So because I've dropped fourth quarter, this intercept that you see is basically the number for fourth quarter. So the mean sales figure during Q4 is 130.2, okay? So what is the sales figure for quarter 1? Quarter 1, the sales figure would be 130.29 less 57.11. So what is this? So if I were to rewrite this, this is basically the quarter 1 figure would be this, less. In fact, it's already negative sign, so so it will be actually. So, oops, 130 point. So this would be 130 plus this one. Okay. So this is my Q1 figure. Okay. So this is my Q1. This is my Q1. Okay. Q2 would be again, I do the same thing. Q2 would be 130 plus what I get is this one, 87. And Q3 would be equal to 130 plus this one. Okay. So as you can see, the maximum sales is happening on the Q4, okay, followed by Q3, followed by Q2, followed by Q1. Okay. Now, as I said, that doesn't matter which one of the quarter you are dropping, the results remain the same. So let's try to figure it out by dropping now, let's say quarter D2. Okay. So if I were to, or for that matter, let's try to drop D1 because that is, it doesn't matter, whichever you drop, you will get the same answer. So let's try to do this with dropping this with D2 as we said. So if I'm dropping D2, so dropping D2 means I'm actually bringing this 2 over here and over here. So I've now dropped D2. Remember again, the idea is to showcase that the results are not changing. So if I'm doing that, let's try to see what happens here. Let's try to see what happens here. So data, you go to data analysis, you go to regression. Here you have to change this because here this is my thing. Okay. And here again, I'm changing this. Here I'm changing this. Okay. And let's try to give the output range somewhere here so that we can compare. Okay, so this is my output range. So the funny thing is now I am getting because I have now dropped D2, this thing, this intercept is basically going to replicate, this intercept is going to replicate my D2, okay, because I've dropped this. So my D2 is 87.87. Now let's try to see whether we got the same result here. You see, we have got the exactly same result here. Here also D2 or the Q2 figure was 87.87, something we are also getting here in this particular case. Now let's try to see what is the figure for D1 or the Q1. Okay, so the Q1 would be 87 plus this one. Okay, so Q1 is 73.18. Let's try to see whether we got the same number here. Q1 is, you see, the same thing. Okay, C1 is 73.18. So it doesn't matter which one. And let's try to check out whether we get the same result for D4 or Q4. This would be this one. Oops. This one plus I just erase this. So you'll find that here also, let's not try to save this. Here also you'll get the same result, okay? Data analysis, okay. So I have 87.87, so this will be 87.87 plus you have for D4 42.42, right? 42.2. So 130.29 is what I'm getting. You see the same result we got here. Okay, so here again you got this Q4 as 130.29. We have got the same result for Q4, something we got for the previous case. So it doesn't matter which one of the dummy you are actually dropping, you are still getting the same file. Okay, so someone is asking, sir, please share the data. Yes, we'll be sharing the data. Dr. Arjun is going to share the data. But first, you just see how we are doing it. And because you're also going to see the video, you can actually replicate what I'm doing right now over here. Okay, so this is the first part, which I said that trying to get an understanding which one of the quarter the sales figure are going to be high or low. The second part of this exercise is we are going to deseasonalize the data, which is basically trying to tell you that this sales figure, because it has got seasonal factor, as you can see, all the p-value of the dummy are highly statistically significant, which is telling me that all the seasonal factors are present. So if I were to take out the seasonal factor, what I do is basically, it's again simple. So again, you run the regression. Now let me erase this. You run the regression to calculate the seasonality. So now what we are doing is we are checking the seasonal factor, or we are actually deseasonalizing the data. Okay, so let's try to deseasonalize the data. So here, what we are doing is we are deseasonalizing the data. Okay. So that's what we are doing here. So here, what you do is you run the regression, and you run the regression. And here now I want the residual, because the residual will play an important role. And let's do this, because my y variable is sales figure. Y variable is the sales figure. This is my sales figure. And my x variable are this dummy variable. This dummy variable or my x variable. Okay, now let's try to get the output over here. And I want the residual to be here. So let's say that I want the output to be here. So this is my, I'll just write the residual, because that I'll be using it. Residuals here. So if I'm running the regression, this is my residuals, right? So this is my residual, what I'm getting. Now, if you plot this residual, you will find that this residual is highly volatile. Okay, so basically the way you do the deseasonalizing the data is very simple. You add the average of the sales figure, you add the average of this average. Okay, you average of this y or the sales figure, That is what I'm getting. And you have to add this. So the deseasonalized data will be y bar plus the residual. So the deseasonalizing the data says data. This is my deseasonalized data. It will be this. F4 I want to give for. You have to give a $sign because again, what is this? This is my sales mean sales value plus you have to add the residual. Okay, so that is going to give me my deseasonalize the data. This is my deseasonalize data. Now you can check that in what way the deseasonalized data. So I have this one, which contain my seasonal factor. Let's first copy and paste this. Copy. Control V. Oops. V. Okay. So this is my deseasonalized data, and my seasonal cell figures is the one. This one. This is my seasonal cells figure. This is my seasonal cells. And you can make out that the deseasonalized data is much less volatile compared to the seasonal cells. Okay, so this is the deseasonalized cells data. Now let's try to compare both of them. Okay. So this is the mean, which I don't want. So let's try to compare both of them. You have to go to insert. You have to go to this one. You can see that the deseasonalized data is much less volatile compared to the seasonal factor. Okay, so if I take out the impact of seasonality, this is how it looks like. Okay, so you can also fit a trend line, and you can try to see that for the deseasonalized data, it is much more stable in terms of. So we have learned a few things here. We have learned how to capture the seasonality. It can be quarterly data, it can be monthly data, it can be annual data. You know, I'm going to do another exercise with annual data, and we have also seen that how you can do this without. You can deseasonalize the data. Okay, so now that I have shown you in any question before I move to the Eviews. So Yogesh is saying, can you repeat the process of deseasonalizing the data? So Yogesh, what we do in case of deseasonalize the data is you first create a dummy variable of the quarterly data. That is step one. Step two is once you have created the dummy variable quarterly data, like the way we have done, okay, over here, see, I've created D1, D2, D3, D4. I've created a dummy variable. And here I have used the if function. You can see it from over here, how I've created the if function. I've used the logical if function. I've created this dummy variable. And then what you do is, the second part of the exercise was, I have to drop one of the dummy because otherwise it will run into the problem of dummy variable trap. Doesn't depend which dummy I am dropping because the results are similar because we did that two exercise. In one case, we dropped D4 And in another case, we dropped D2. Irrespective of which dummy you are dropping, you will still get the same result that we have shown using the Excel file, right? And so let's say that you have dropped D, in this case, I have dropped D2, okay? So the intercept will capture the Q2 result. So please keep this in mind, whichever dummy I'm dropping. Again, what are the dummy? Dummy are representing each quarter. So let's say I'm dropping the dummy for Q2, the intercept will capture Q2 sales figure, okay? If I'm dropping dummy for Q1, the intercept is going to capture sales figure for Q1. If I'm dropping dummy 4, the intercept is going to capture the sales figure for Q4. Now, having said that, what you do in the next step, step number 2, is you run this regression on this dummy variable, you collect the residual, okay, and you also take the average of the sales price and you add to that average. Let's say in this case, my average, we were getting average value as we were getting average as this thing, right? Where is this? We are getting the average sales price as 147, right? So this is what we are getting, or 96. So you have to add this average sales price with this residual, okay? And then the transform data, which is again average sales price plus the residual. How I'm getting the residual? After running the regression of Y or cells on D1, D2, D3, and D4. I run the regression, I collect the residual, I add this average sales price with the residual. That data which I get is the deseasonalized data. Okay, so that's my deseasonalized data. You can see that I've added the average sales price with the residuals. The residuals are over here. So is that clear? Okay, so let me now showcase this in Eviews, okay, because we have, so let's not save the data, so don't save the data. Okay, let's try to share this screen one more time. Just let me open this with Excel. In Excel, things become much more easier, as you will see. So just give me a second. So let's try to do this exercise using Excel. So for that, let me share the data again. So let's see. Let's try to open the data. Just hang on. Open using okay, so here I have the same data as you can see, but let's try to open this data using Eviews. Eviews. Let me share this. Are you able to see the Eviews file when I've shared?
Yes.
Okay. So now you go to File, you go to Open, and I collect the data here. The data is this one. My data is which one? I think the impact of an event or impact. This one. No, this is the impact of an event. This one. impact of it. Yeah, this is the fact. Okay, now you see that here it is giving me the quarterly data. As you can see, 1986, quarter 1, quarter 2, quarter 3, quarter 4, so on and so forth. So basically you do next. And here I have my data. Okay, so let's try to see whether how the observation. So it's already saying that it is looking, it has actually transported the quarterly data over here. Now the thing is, I can create the dummy variable here, and it becomes very easy. You know, it becomes very easy to do all this exercise. And so basically, what you do here is, so let's try to create quick. You go to generate series, and let's say that I'm trying to create dummy 1, which is basically at the rate quarter equal to 1. Okay. You see, I've now created the dummy. All of you can see this. So here is the command. Okay, dummy 1 at the rate quarter equal to 1. Okay, so this is, see, when I transported the data, when I actually imported the data, I just had this variables. Okay, so which are the variables which I had? This is my sales figure. I have the trend figure. I have RPDI, and this was the consumer confidence index. So that's how the data look like. If I open this, so this is how the data looked like. Okay, so this is the sales figure. Again, what type of sales figure? This is my quarterly sales figure. I also have the trend, trying to understand that over a period of time whether the quarterly sales figure has increased, decreased, in what way it has changed. Then I have real personal disposable income. That's what RPDI stands for. And I also have consumer confidence index, which is given as CONF. Okay. So the first thing you can also do, you can try out a few things. I can run a regression. LS stand for least square, and my dependent variable is sales. Independent variable are RPDI, conf, as in consumer conf, and I also have a trend. Okay, if I run this regression, I clearly see that this is how the regression looks like. Let's close this. No, I don't want to, or maybe I'll save this group. Yes, let's say that group 1. Okay. So this is how, but here I don't have the dummy. Okay, so let's try to save this. Delete, no. Let's call this equation 1. Now let's try to introduce the dummy, because I've already introduced the dummy 1. So the Eviews is smart enough to understand this. So you don't have to create anything more. So all you have to do is to write ls cells, or let me show you even much easier than that. You go to quick, you go to estimate equation, and I know that my dependent variable is cells. Then I have intercept. I've already taken. Please note that in Eviews, C stand for intercept. Okay. What did I tell you when I was doing that exercise for in Excel? That you can drop any one of the dummy and the answer will be same. And I'm going to show you again here. So let's say cells C, and then let's do this in the sense that let's just try to work with the dummy. Okay, because here I don't have anything else. So I can rewrite this as, this is the command, expand at the rate quarter and one. Okay, so what does it mean? It means that I have actually used 4 dummy. Okay, Q1, Q2, Q3, Q4. Okay, like what we did in Excel. But here, what I'm saying is I'm dropping the first dummy or the Q1. Okay, now let's try to see whether it gives any result or not. Okay, bingo. So here you see that the same result we got while we did it in Excel. So let me save on this. So here, basically what he's saying that the sales figure is highly statistically significant, because you see that for each one of the quarter, the p-value is less than 0.1, okay? P-value of the probability, okay? So let's try to save this. Again, what I said, that doesn't depend which quarter I'm saving, okay? I'm going to get the same, I'm going to get the, so view representation. So this is how the representation looks like. So I can do the same thing, but for, let's say if I, instead of drop 1, I say drop 2, okay? It will give me, so let's try to name this equation 2, okay? And now we have got equation 1, okay? Now let's try to see side by side. Here, view representation, estimation output, okay? So please note, here which one we have dropped? We have dropped, I have quarter 1, quarter 2, quarter 3, quarter 4, right? Here I have dropped, so basically this C is representing what? Quarter 1. So quarter 1 is 73.18. And here, what is quarter 1? Quarter 1 is 87.87 less 14.69. If you do that, you will find 73.18, exactly similar to what I got in quarter 1. Okay, guys? That doesn't matter. So I think I have another question. Do I have any question? Please ask any question, because this is so simple. As you can see from here, I can now drop the quarter 3 also. Okay? Again, I can get the same result. So again, if I drop, let's name this equation 3, and now I have quarter 3. So if I'm dropping quarter 3 in this case, right, I'm showing side by side. Basically, this quarter 3 is basically 101, okay? Now the quarter 3 is basically 101. Why? Because from equation 1, I'm getting quarter 3 as 73.18 plus 27.96. If you add these two, you will get 101. Again, from this equation, let's try to figure out what is quarter 1. So quarter 1 would be 101. 0.14 less 27.96. That would be quarter 1, which is basically what I get over here, 73.18, which is quarter 1. Okay. So this is how you do the dummy variable in terms of capturing the seasonality, in terms of this thing. And the best part is you can see that you can check for the residual. If I go to the residual and I go to the representation, just estimate actual. Okay, so this is my residual here. Here also you'll see the same residual I'm getting. Okay, you see all the residual are same. You can check it yourself. And how I go for the you see, for all this thing. So that's what we are trying to argue. Doesn't matter which one of the dummy you are dropping. Ultimately, the results are same. And what we are trying to argue here is how you deseasonalize the data. Basically, what you have to do is you go to this. Okay, I can save the residual, copy, and okay, copy to the highest precision, and let's see, I generate a series. I say this is the, let's call this residual, okay? Because it's a reserved thing. Okay, let's call this E, okay? ER, okay? ER stands for error. No, quick. Estimate option. I think the residual is already there. That's why it's not taking. You see, the residual is already there. So all you have to do is you have to take this average of the cells figure, which we have already got, and then you add this with the residual, and the thing that you get is what is called the deseasonalize the data. Okay, so that is number